4.2, relating fractions, decimals, and mixed numbers. Okay? Basically, what we're going to talk about is two things today. Okay? We're going to talk about changing fractions to decimals. That's number one. Number two, is changing decimals to fractions. Okay? Now, let's remind ourselves. A reminder. Fractions are always expressed in simplest form. Okay? To put it differently, you must always reduce fractions. Okay, you must always reduce fractions. So, looking at our first goal today, changing fractions to decimals. It's fairly simplistic because most of the fractions that you're going to have are going to look like this. For example, 3 over 10 or 9 over 100 or 22 over 1,000. Okay? They're all going to be in powers of 10 on the denominator. Okay? So let's go back and remind ourselves and review our place values. First place value is the tenths. Second place value is the hundredths. Okay, third place value is the thousandths. Fourth one is the 10,000ths. Okay, and if we think of fractions for each of those, this is 1 over 10, 1 over 100, 1 over 1,000, and 1 over 10,000. Okay, so if I have the fraction 3 over 10, it would go there. 9 over 100 is in that place value. And 22 over 1,000 is in that place value. Okay, so this would have to be 0.3. This would have to be 0.09. And this would have to be 0.022. So anytime that you have a 10 on the bottom, then whatever number's on top goes right behind the decimal. Now, let's look at another example that's got more than just one number in it. Let's see here. We're doing one similar to that. There we go. 2 and 37 over 100. 2 and 37 over 100. So the hundredths place value is here, second blank. So I've got to take 37 and put it into those blanks, which means I have 0.37. So the fraction is 0.37. The 2 I just bring in front. So it's 2.37. Okay? Not real hard. Let me give you one that I want you to do on your own. Let's see here. $62 over 1,000. 62 over 1,000. I want you to make 62 over 1,000 a decimal. Jesse, what is it? Call it out. Right. 0.062. Okay? Because once again, 0.062, that's the tenths, that's the hundredths, and that's the thousandths. Okay? So that's why it's 0.062, is because it's 62 over 1,000. Okay? Most people don't really struggle with that part of this lesson. The part that they maybe struggle a little bit with, and really, realistically, it's only because they forget to reduce things, is changing a decimal to a fraction. Okay? And like I said, most of the time it's just a matter of you forget to reduce it, is usually how you miss problems in this section. Let's look at this one. 0.05. I want to take 0.05 and make it a fraction in lowest terms. Now, let me make sure that they're going to require you to... Yes. All right, now, so the first thing is we have to identify our place value. We have the tenths, and then we have the hundredths. So that is 5 over 100. Now, you are not finished. You must list that as well as taking 5 over 100 and dividing it by 5 over 5, because we have to reduce the fraction to lowest terms. 5 goes into 5 one time, 5 goes into 100 20 times. And so that would be 1 over 20. So the two fractions together are your answer. Okay? Let's look at one that is a mixed decimal. 2.8. Doesn't change. That is the tenths place value. So therefore, I put 8 over 10. The 2 just comes in front of the fraction. Now, it is not finished yet, so I've got to take 2 and 8 over 10 and divide it by 2 over 2. 2 into 8 goes 4 times. 2 into 10 goes 5 times. Be 2 and 4 over 5. 2 and 8 over 10, and 2 and 4/5. That would be the correct answer, both of them. Emma? How do I know what to divide it by? Okay. You look at the 8 over 10 and you say, what is the greatest common factor of 8 and 10? And that is 2. Remember, that is what we did in section 1 of chapter 4. Okay, so that's what we're going to grade tomorrow along with 4.2. So hopefully you've done that properly. But that's how you reduce it. Okay? All right, I want you to do this one on your own. 14.55. 14.55. This is number 23. So you have to get the original fraction that you start with, and then you have to list the fraction that's in simplest form. Okay. Let's see. I want the first one. Owen. No, the first one.
Oh, the first one.
The original fraction before you reduced it.
The original fraction. 14 and 55.
Yeah. 14 and 55 over 100 is the original fraction. Okay? But 55 over 100 can be reduced. Okay? And we're going to reduce it. The greatest common factor between 55 and 100 is 5. So we divide by 5 to the top and the bottom. Goes into that 11 times, goes into that 20 times. So 14 and 11 over 20, those are your two fractions. You must have both fractions for it to be correct. Now, what if you run into one that looks like this? 0.13. Okay? Well, that's 13 over 100, and 13 is prime. So there is no common factors between 13 and 100, so our answer is just 13 over 100. Okay? If it can't reduce, then you only list the original fraction. If it can be reduced, then you list the original fraction along with simplest form. Okay, now, as I read the directions, they want you to list two equivalent fractions. Okay, so I have to take the 13 over 100 and do what I did in 4.1 and multiply it by 2 over 2, which is equal to 26 over 200. So this, along with the 13 over 100, is your answer. There's only one of those. I think that's the only one in the work that you have to do that to. Okay. So since we couldn't reduce it and they want two equivalent fractions, then I go back to what I learned in 4.1. To increase the fraction, we multiply by 2 over 2. Okay? Now, number 27 says 4 800ths. Okay? They want you to write it as a decimal and as a fraction. Okay, so what is the decimal number that is 4 800ths? What would the decimal number be? Colton? Yeah, 4.08. Okay, that a little better. 4.08. Now, what is the fraction? What is the fraction that number represents? Okay, listen to what I'm saying. What is the fraction that those words represent? Celine?
4 800.
Right. 4 and 8 over 100. Those two would be your answer. The reason we don't reduce 4 and 8 over 100 is because they want what the words represent. Okay? The words don't represent what you can reduce that down to. Okay? You can reduce that down to 4 and 2/25. But that's not what those words say. Okay? So that's the reason we don't reduce the 4 and 8 over 100 in that problem. It's because they want to know what those words stand for. Okay? Now, I want to look at one of the algebra problems that they always, put in here. All right, 3 over 4 times n over n is equal to 750 over 1,000. So, they want to know, what did I do to 3 over 4 to make it 750 over 1,000? I multiplied by a fraction, and that fraction has to be equal to 1. So what did I multiply 3 by to get to 750? Raise your hand. Don't call out numbers because I don't want people just guessing. And if you are going to guess, then we're going to at least control the guessing. What, Jesse? 250? Yeah. So 250 is your guess. Yes? Then that would be correct. No jumping for joy in the classroom, please. Yes, 250 is what I multiplied the top and bottom by. So, n would have to equal 250. Okay, and how you get that is basically what Jesse said he did, is he divided 3 into 750. You divide 3 into 750, it goes 250 times, so therefore I had to multiply by 250. Okay, now, what about this one? 0.5 times n equals 5. Okay, 0.5 times n equals 5. What did I multiply by there? Xander? 1? No, not 1. 0.5 times 1 would be 0.5. Zach? 10. We multiplied by 10 because the decimal moved from 0.5 one place to the right. The decimal moved one place to the right. To move it one place to the right, we multiply by 10. Okay? Now, your homework. Your homework is, make sure you write this down because it's not the same that is on RenWeb. I'm sort of cutting it down or cutting it, I don't know what I'm doing. It's 4.2, 9 through 37. It was a lot more than that originally, so. And 42 and 44. Okay, 9 through 37 and 42 through 44.